Good day everyone. I am now going to discuss about solving problems involving hypothesis testing. Problem number 1. A principal at a certain school claims that the students in his school are above average. A random sample of 30 students' IQ scores have a mean score of 112.5. Is there a sufficient evidence to support the principal's claim? The mean population IQ is 100 with a standard deviation of 15. Use alpha or level of significance is equal to 0.05. Given n is equal to 30, mu or mean or population mean is equal to 100, alpha or level of significance is 0.05, sample mean is equal to 112.5, and the standard deviation is 15. Formulation of null and alternative hypothesis. HO, mu is equal to 100. H1 or alternative hypothesis, mu is greater than 100. Level of significance, alpha is equal to 0.05. Select the appropriate and compute test statistic. So we will use z-test since n is greater than or equal to 30. So z is equal to x bar minus mu over the sigma multiplied by the square root of n. So it is equal to 112.5 minus 100 over 15 multiplied by square root of 30. That would be equal to 0.8333 multiplied by square root of 30. So that is 4.56. Now we are going to establish the critical region or regions. Based on the alternative hypothesis, this is a one-tailed test or right-tailed test with critical regions z is greater than z alpha, where z alpha is equal to z 0.05. So based on the table, that would be equal to 1.64. The critical region or the shaded part is illustrated below. Now let's make a statistical decision. Since 4.56 is greater than 1.64 is true, HO or the null hypothesis is rejected. From the illustration, 4.56 lies within the critical region. Now let's draw the appropriate conclusion. So there is enough evidence to reject the null hypothesis. Problem number 2. In a certain city, a school administrator hypothesized that students enroll in schools within 5 kilometers from their homes. To check this claim, you asked 30 students from the said city, and you found that the mean distance between their schools and their homes is 5.3 kilometers with standard deviation of 0.2 kilometers. Is the true mean greater than the hypothesized mean? Use alpha is equal to 0.05. Given n or is equal to 30, mean is equal to 5, the standard deviation is 0.2, alpha or the level of significance is 0.05, and the sample mean is 5.3. Formulation of null and alternative hypothesis. HO, mean is equal to 5. That is the population mean is equal to 5. H1 or the alternative hypothesis, mu or the population mean is greater than 5. Level of significance. Alpha is equal to 0.05. Select the appropriate and compute test statistic. So we will now use z-test since the n is greater than or equal to 30. So z is equal to x bar minus mu over the sigma multiplied by square root of n. X bar is the sample mean minus mu, which is the population mean, over the population standard deviation multiplied by square root of n. That would be equal to 5.3 minus 5 over 0.2 multiplied by square root of 30. That is 0.3 over 0.2 multiplied by square root of 30. That is 1.5 multiplied by square root of 30. That is 8.22. Let's now establish the critical region or regions. Based on the alternative hypothesis, this is a one-tailed test or right-tailed test with critical regions Z is greater than Z alpha, where Z alpha is equal to Z 0.05, which is equal to 1.64 based on the table. The critical region or the shaded part is illustrated below. Make a statistical decision. Since 8.22 is greater than 1.64 is true, HO or the null hypothesis is rejected. From the illustration, 8.22 lies within the critical region. Draw the appropriate conclusion. There is enough evidence to conclude that the true mean is greater than the hypothesized mean. Problem number 3. Conduct a t-test for the null hypothesis HO. Mu is equal to 100 against the alternative hypothesis HO. Mu is greater than 110 based on 15 random observations. The sample mean is 110 and the sample standard deviation is 8. Use alpha is equal to 0.05. Given n is equal to 15, mu is equal to 100, alpha is equal to 0.05, s is equal to 8, x bar is equal to 110. N is number of samples, mu is the population mean, alpha is the level of significance, S is sample standard deviation, x bar is sample mean. So the degrees of freedom n-1, which is equal to 14. Formulation of null and alternative hypothesis. HO, mu is equal to 100. H1, mu is greater than 100. Level of significance. Alpha is equal to 0.05. Select the appropriate and compute t-test statistic. So t is equal to x bar minus mu over s over square root of n. So we will use the t-test. So that would be equal to 110 minus 100 over s over square root of 15, which is equal to 110 minus 100 over 8 multiplied by square root of 15. That is equal to 10 over 8 multiplied by square root of 15, which is equal to 4.84. Establish the critical regions. Based on the alternative hypothesis or H1, this is a one-tailed test or right-tailed test with critical regions. T is greater than T alpha 14, where T alpha 14 is equal to 1.761. So the critical region is illustrated below. Make a statistical decision. Since 4.84 is greater than 1.761 is true, HO or the null hypothesis is rejected. From the illustration, 4.84 lies within the critical region. Draw the appropriate conclusion. So there is enough evidence to conclude that the mean is greater than 100. Now here are the references. Thank you very much for watching and listening. Please subscribe to Analyze Math for more.